Okay, so we're going to put these notes in page 26 of your notebook, so it gets folded in half. And then the first page is got some vocabulary in here that's pretty important. So the first thing is the slope is your common difference, right? Because what we're working on now is all linear stuff. So instead of saying common difference now, we're going to use the word slope. And then slope is always written in or will sometimes be written in a fraction. It is technically always written in a fraction, but sometimes that fraction simplifies to a nice number or changes into a nice number. So the fraction is on top, we have the math for y, and then on the bottom we have the math for our x's in our table. And remember, if it's a common difference, the only math that we will see is adding or subtracting. All right. The y-intercept is going to be the number with x at time 0. Okay. So again, it's the number with x at time 0. So if I have an example here, we have 2x plus 3, okay? This plus 3 is our y-intercept. This 2 is our slope or our common difference, okay? It's always attached to the x. Y-intercept is always not attached. And again, it starts at time 0 because our x is just an x. It does not have x minus 1 with it. Now, you guys didn't know this, but this whole time we've been working with slope-intercept form, and that's because it's linear equations that start at time 0. Okay, so some more examples are y equals -5 plus 2x, or we have y equals 3x minus 7. These are all starting at time 0 because we have just the x here. So these are all slope-intercept form, which you'll see me abbreviate as SIF. Now we got to be careful before we go any further. We need to stop and we need to remember that we look at graphs from left to right. We read them like books, okay? So please remember that. So when we look at this first example here, we go from left to right. So starting with our left point, which is right here, that x value is 0, right? The x value, if I go straight up, is 0. The y value in this case is -3. At our next point, the x value is 1. The y value here is -1. With our next point, our x value is 2, and I know to look there because this is my x-axis. That will give me my x values. I know to look at this bold up and down line because it's my y-axis, which means it has all my y values, and in this case it's a 1. Our next point, the x value is 3, the y value is also 3, okay? Now, what we're going to do is we are going to identify our y-intercept. Our y-intercept is the number with time 0. So here on my table, this is my y-intercept. And I'm going to abbreviate that y-in. On my graph, it was my first dot. So right here is my y-intercept. And be careful or notice that the y-intercept is on the y-axis, right? It's on the up and down bold line. Every time it's going to be there. So for my answer, my y-intercept is going to be -3. Next up, we have moving from point to point. So moving from a left point to a right point. So let's zoom in here. So how do we move from this left point to this right point? Well, we go up. We go up 1, 2. So we go up 2, and then we go right 1. So I'm going to write that down. So we go up 2, right 1. Okay. Now if I look at my equation, or I'm sorry, if I look at my table here, as I go down my y sides, I'm adding by 2, right? 1 plus 2 is 3. That's how we know. And it's only adding or subtracting. If I go on my x's side, I'm adding by 1. Well, let's think about this. When you go up in math, that's a positive thing. And we went up 2, so we went up plus 2. Well, we see that in our table for the y, so that lines up. That's good. When we go right 1, that's a positive thing too. So that means we have plus 1, which we see for our x's. So that plus 1 is for our x's. If I'm going to write the explicit equation, well, I started here with negative 3 at time 0, and I'm adding by 2 as I go down. So I have y equals negative 3, adding by 2, and that's my x. Or if you write it in a different form, the other way where it's the same but flipped, we have y equals that positive 2x with that negative 3. Both of those are good. Be careful. Know that you know how to go from this form to this form, okay? All right, I want you guys to try the next side on your own. So again, try the next side. So again, I want you to try this on your own. Really try. I want you to see if you know how to do it. Okay, so here's the table all filled out. Our first point is this one, because we go left to right, and that x value is negative 1, that y value is 4. The next point is 0 point, and then at 3 on the y. Then we have the x value is 1 and the y value is 2. The next one we have the x value is 2, the y value is 1. Then we have the y value 0, right? It's not up by anything, and then it's on 3 for the x. The next one, the x value is 4 and the y value is negative 1. As we go down the table on the y sides, we're adding by 1. I'm sorry, on the x sides, we're adding by 1. On the y sides, we are subtracting 1. Our y-intercept is 3. Remember, y-intercept is with x at time 0, and on our graph, it is on the y-axis. The movement from going left to right, we went down 1, right 1. So I went down 1, right 1. This matches up with going down as a negative thing, so we went down 1, which is subtracting 1. Going to the right is plus 1. Well, if I look at my table, where am I subtracting 1? I'm subtracting 1 for my y's. Where am I going right 1? Well, I'm adding by 1 on my table. I am adding 1 for the x's. When I write the explicit equation here, at time 0 we had 3, and we are going down by negative 1. So when we write the explicit, it's going to be 3 minus 1x. Or when I flip this, it's y equals negative 1x plus 3. Notice how the negative and the x stay with the 1. This 3 is positive, so when I rewrite it and put it in the back, I need to show still that it's positive by using a plus sign. All right, the next one here, I will get you started. So there's no dots, so you got to find the dots, okay? Well, in order to find the dots, we need to see where our graph passes through a grid intersection. So when I look here, I'm going to go down my graph. Here is where the graph passes through a grid intersection. So I am going to put a point there. I'm going to follow that line again. I'm going to keep going, find where my line passes through a grid intersection. Oh, here's one right here. Keep going again, and here's another one. Okay, so that's how you do that. So go ahead. I want you to do the rest of this one, and I want you to try this next one, okay? So try those next two on your own. All right, so looking at the bottom left here, in gray, here are our points, 0, 3, 1, negative 2, 2, negative 7. As we go down the x sides, we're adding by 1. As we go down the y sides, we are subtracting by 5 because it's getting negative, so I definitely know I'm subtracting. And when I fill out the rest of the table, here are the rest of the points we could potentially see. Our y-intercept is 3. Again, y-intercept is the number with x at time 0. We can also find it on the y-axis. The movement going from point to point, again going from left to right, is going down 5, right 1. Down 5 lines up with minusing 5 for our y's. Right 1 goes with adding by 1 for our x's. If we write the explicit equation, starting at time 0, we had 3, and we are subtracting by 5 down our table, so we can write it as 3 minus 5x, or y equals negative 5x plus 3. Again, see how that negative and the x stay with that 5. See how this 3 stays positive, but now we have to show it with a plus sign in the second one. Next up, we have this graph. Here are all the points. We have 0, negative 5, 1, negative 2, 2, 1, 3, 4, 5, 7. We're adding by 3's for our x's. If you didn't know what it was happening with these first two, well, you know from 1 to 4, you could add 3, okay? For our x's, we're adding by 1. Our final point would be 6 and 10 for this table. Our y-intercept is negative 5 because, again, the y-intercept is the number with x at time 0. And if you look for it on the graph, it's on the x-axis. When I write the explicit equation here, starting at time 0, we had a negative 5, and we were adding by 3. So when I write that, we're starting with negative 5, adding by 3 every step. Again, the x stays with what we do down the table for the y side. Or, if you flip-flop it, it's 3x minus 5. So this 3x, the x stays with 3 and it stays positive. Well, that's what we have here. Minus 5, or negative 5x, when I write in the back, stays negative. But now we just can say minus. Remember, negative and minus correlate with one another. All right, the next one, I want you to really try this. See if you can do it without a table. If you need the table, totally cool. But see if you can try it without the table. Okay, so here are all the points. Our y-intercept happens on the y-axis, which in this case is negative 1. When we move on our graph, we go up 4, right 1. So I wrote that down, up 4, right 1. Now, hopefully you looked, but all of these, we went right 1. But we didn't do anything with that right 1 in our equation, right? We didn't do anything with having that plus 1 for our x's. The only one we focused on was what we did going up or down, okay? Which in this case we went up 4, which is a positive thing. So this is how we get y equals negative 1, which is our y-intercept, where we would start with at time 0, and then we were adding by 4 going up, okay? Because if I did my table here, it would look like this, right? And here we are adding by 4. This we were adding by 1, but we don't use that because we've been using that. We started with that time 0, okay? Later, what we do on the right, if it's not 1, will become important, all right? So that's all of the notes. I hope you guys have a good day. Don't forget, this is going to go in your notebook on page 26.